So if you have a standard band gap 1.2 volt and you want a lower voltage, you can still do that by using this circuit. So what will be this voltage?
1.2 R2 by R1.
1.2 times. Okay, so just use a resistor divider. In fact, you can directly do this also. Connect a 1.2 volt here, but the problem is this will load your previous stage. This may disturb the band gap voltage, and you don't want to load that. So you have to use a buffer, and this guy is doing nothing but is buffering your. You can do this or you can do this also. It will give you the same result. Okay. Advantage with this is if you take the feedback here, then it will behave more like a LDO, and if you want a higher voltage, you can get a higher voltage also from this. Okay. So this is one way. The only thing now it's going to cost you 1 op amp and 2 more resistors, which means more area and more power consumption. So most of the time, if you are not worried, you just need a 1 voltage which is lower than 1 volt, 0.6 volt or so, you can use this sub 1 volt band gap. If you use a multiple, if you want a multiple band gap voltages references, and some cases we require. So let's say you need 1.2 volt, 0.4 volt, 0.5 volt, all those values. You can just tap 1.2 volt and use the buffer resistor divider and tap multiple. So you can use more resistors and keep tapping the voltages. So you can generate multiple references out of here. As long as this coefficient of temperature coefficient of these resistors you are using are same, it will not affect your band gap curve. It will only scale up or down depending upon the values you choose. Okay. So now next topic is your linear regulator. Also called LDO, low dropout regulator, when operated at low VDD minus V out, which is nothing but V drop. Okay. So let's first look at the applications. First application. Sub-regulators. When I say sub-regulators, so you have your DC to DC converter or switching regulator. So let's say this guy is 3.6 volt, you regulate at 1.25 volt and put this LDO with 50 millivolt V drop, and this is your V out. Okay. So this is called sub regulator. So most of the portion step down, basically the larger step down ratio is achieved by switching regulator, and mainly due to efficiency reason, we know. And since this guy has ripple, and this will be much cleaner. This what LDO will do, it will filter out your ripple and provide you a cleaner output. Okay, and it's like very commonly used in any system, especially noise sensitive application, to achieve higher efficiency as well as smaller output ripple. So what you are doing, if you want 1.2 volt, you design the LDO for dropout voltage of 50 millivolt, and your switching regulator will, instead of directly regulating to 1.2 volt, it will regulate to 1.25 volt, 50 millivolt extra, which is the overhead or dropout voltage in your LDO. So the output you get is 1.2 volt regulated. Okay. So second application, parallel or auxiliary current source. So in this case they are cascaded. Now if you connect them parallel, let's see what happens. So you have switching regulator again, and this is my V out. VDD is, let's say, 3.6 volt, and I want V out equal to 1.2 volt. So what you do, and now this won't be LDO actually, because dropout voltage would be much larger. So I will just call it linear regulator. Okay. So what would happen actually? So if you make this regulator very high bandwidth, and your switching regulator has, let's say, limited bandwidth, so you make your linear regulator bandwidth much larger than your switching regulator bandwidth. So during transient, what will happen? All the fast current requirement will be met by your linear regulator, and when output is settled, you can back off, and all the load will be supplied by your switching regulator. Okay. So all the average current is being supplied by your switching regulator, and linear regulator can supply only current during transient. Okay. So linear Okay. So, the advantage is achieves faster transient response. So, in your cell phone there are two cases, like one current from the battery will be drawn as a steady state current or average current. On top of that you will have some activities going on which are like a transient activities. I mean, they will come for a very short duration and then go away. Okay. So, what would happen during that time, this linear regulator will kick in and supply that current and then back off. So, that another advantage with this is, like, you can share the transient load between switching regulator and linear. So, you do not have to design your switching regulator for a very higher current. So, let us say your average current requirement is 1 amp, but your peak current requirement might be 2 amp or so due to transient. So, the transient glitches come, let us say, for few microseconds for 2 amp and then go away and then again settles to 1 amp. Okay. So, if you have to cater all, like, total 2 amp current from switching regulator, you have to design it for 2 amp, which means you have to use a bigger FETs and all those. Okay. And which means you may incur more switching losses also in that, because gate driver gate cap size will be larger here. So, you design your switching regulator for 1 amp average and 1 amp transient will be supplied by your linear regulator. Okay. And since this transient is coming only once in a while, then you will not lose that much efficiency. You will lose some efficiency, but not that much, because most of the time it will be supplying 1 amp average current and the 2 amp peak will happen only once in a while. Okay. So, it depends what kind of system you have. If you require this thing, then you can add this linear regulator in parallel and basically get a better transient response. Okay. Obviously, the third application could be a regular power supply. So, when I say regular power supply, higher load current if V drop is low, usually less than 10% of the output. Okay. Lighter load currents if V drop is high. When I say lighter load current, usually less than 50 milliamp or so. So, most of the analog applications, your PLLs or your sensors, analog front end, all those can be supplied with these LDOs, because they are much cleaner compared to your switching regulator.